Oh, friends of chemistry.
Don't do that. Put it down. Get rid of that thing. I will shoot my pencil through it.
That's not Martha.
With the
All right.
power of my
Martha,
mind.
you problem number 4. This is review questions for module 13.
I got that imposter out of here. I'm the real one.
Okay, don't break the styrofoam now. Number 4.
What is a state function? Give 2 examples.
So as we said in the previous video, we're not talking about an event where you might have, the British Queen along with the President of the United States. That's a state
is
dinner.
Any quantity that depends solely on the final destination, not the way you get to that destination.
Read that again.
A state function is any quantity that depends solely on the end destination, not on the route.
So it depends on the end destination, not the method of arrival. So give 2 examples.
Well, there's if
That's not really a state function, right? That's
yeah.
okay. So we're going to be working with one in this chapter lot here. What does Hess's law say?
Enthalpy is a state function and is therefore independent of path.
So enthalpy is a state function. So that's one example.
Yeah.
What's another example of a state function?
Heat. Am I right?
Say again?
Heat.
Heat. What do you mean? Well, we use enthalpy for a significant part of the chapter, right? Yeah. And then what do we talk about? What's delta G that we learn on page 446?
Gibbs free energy.
Right. So if Gibbs free energy is related on the delta H, right, the enthalpy.
So I guess that's an example of enthalpy.
No,
I mean,
what we're looking
functions.
Yes, we're looking for an example of a state function. Okay.
Yeah.
So the Gibbs free energy is also an example of state function. Okay, let's look at number 5. Please read that.
Which of the following substances will have a delta H under F degree, subscript
an enthalpy
F
of formation
degree of 0? Okay, so we got NaOH aqueous. Na plus aqueous. O2 gas. Oxygen gas. Like single molecule of oxygen.
Just says O.
Yep. Cl2. gas. H2, liquid.
Is that it?
Yeah.
Okay. So what is the question? We want to know.
Which one is going to have an, what's it called?
What's that term? Where's it defined?
Something to do with state function.
True.
Enthalpy formation.
Read it. What does it say?
The standard change in enthalpy of any reaction.
The standard change in enthalpy is delta H degrees is the standard change in enthalpy.
Okay.
And this is defined on page what?
431.
Okay. What does it say down here?
The standard enthalpy of formation of an element in its elemental form is 0.
Yes.
So
if we want to find the standard enthalpy of formation of
why
these.
Why do you write chlorine in script?
I don't know.
Cursive, whatever.
So which of these are in their elemental forms? Is NaOH?
No.
Obviously not. How about this ion?
No.
How about O2?
Yeah.
Gas. Yeah. How about O gas?
Nope.
How about Cl2 gas?
Yep.
How about H2 liquid?
Can do.
Is that its elemental form?
It doesn't often appear as a liquid in nature.
No, the gas is the elemental form. This has to be under pressure. Like that truck that we saw the other day with liquid hydrogen in it. It has to be under a lot of pressure.
Still not as cold as liquid helium, though.
So not. Remember, this depends on the state, right? This has to do with state.
Yeah.
So these are the ones.
Mm-hmm.
Okay?
Okay, 6.
What's this symbol stand for again?
Standard enthalpy.
Okay, should we say it was on page
431.
431?
Yes.
Okay.
Yeah.
Look at that.
What did I tell you?
It's the standard
enthalpy. Change in enthalpy.
Standard change in enthalpy. The delta H is called the enthalpy. The delta H subscript F is the enthalpy of formation. The standard change in enthalpy is delta H degrees. So delta H enthalpy, right?
Mm-hmm.
What's delta H F? Enthalpy
of formation.
What's delta H F degrees?
That's the standard change in enthalpy.
Good. Okay. Are we ready for number 6?
Yes.
Did we read it already?
Which of the following diagrams indicates an endothermic reaction? What is the delta H of that reaction?
Okay. So when we're drawing these diagrams, you got 0. Right?
Yeah.
It looks something like this. Here. About there. And then this one. All right. So what do we call the different parts on this reaction diagram, Martin? How do we think of these parts? the beginning part here, right?
Mm-hmm.
This bit here.
You can end up with more energy.
What do we call this part?
Endothermic. That's the intermediate state.
This height is called the
activation energy.
So let's look at this baby here. It goes from here to the top of that. Wow. Big difference in activation energy, right?
Mm-hmm.
So which one is harder to start? This one, obviously. Okay. So
the first one, however, is endothermic.
These here are the reactants, right? And these here are the products. Right?
Yeah.
Okay. So an endothermic reaction is one that will have a what kind of delta H? Positive or negative?
Positive.
Mm-hmm.
I think that's 65. No, 65. Yeah, that's a 65. So it goes from 15 to 65. So that's a 50. That's a delta H of 50 units.
Approximately, yeah. So the endothermic reaction, they're going to be at a lower or higher energy. The reactants. Did I label this right? I do this all the time. That is the funniest thing. Why do I do that? No, this is right. Product. Gosh, I cannot think straight. Sorry, product. This is the reactants. Of course it is. This is the beginning of the reaction. So here, the products are at higher energy state than the reactants were. And here, the products are at a lower energy state than the reactants were. Mm-hmm. So for an endothermic reaction, we want the ones where the reactants are at a lower energy than the product. So which one is that?
That's the exothermic. What?
We want to know which one is the endothermic one.
Right, it's the first one.
Yeah, thank you. Sorry. I don't think we said it clearly. Number 1, right? Not number 2. This is 1. And this is 2. So the endothermic one is the one where the reactants are at a lower energy than the products are, or the products are at a higher energy than the reactants were. Right?
Yep.
Okay, so it's energy diagram number 1.
Yep.
Okay. We're going to pause here and come back with another video for number 7.